Let's take a look at a problem together to get you ready for the AP Calc exam. Now this particular problem will cover concepts that can show up to 13% of the time on the AP Calc AB exam. If you want to try the problem first on your own, go ahead and pause the video now. Otherwise, let's go ahead and take a look at the problem together. The question is, what is the slope of the tangent line to the curve y cubed minus xy squared plus x cubed is equal to 5 at the point 1, 2? When they ask for the slope, that's just going to be the derivative or the instantaneous rate of change to this curve. We see that our equation has some x's and y's, so we should be thinking of implicit differentiation. And we're given this point of 1, 2, so that's the location that we have to find the slope of the tangent line for. Alright, so here is our original equation. And to find the slope of that tangent line, let's go ahead and find the derivative of both sides of this equation. So let's go ahead and take d dx of both sides. Starting off with the derivative of y cubed, we can use the power rule. That's going to be 3y to the second power. And because we're completing implicit differentiation, anytime we have the derivative of something with a y in it, we're going to put this dy dx next to it, right? And then next, let's go ahead and take the derivative of this second term. This is a product, so we're going to have to use the product rule here. Let's go ahead and give this section a hug to keep things nice and organized. For the product rule, let's take the y squared and multiply that by the derivative of x, which is just going to be 1. Let's go ahead and add on x multiplied by the derivative of y squared. The derivative of y squared is going to be 2y raised to the first power. I'm not going to write that. But then again, this part has a y. So if we go ahead and take the derivative of anything with the y, remember we need to put this dy dx next to it as well. Okay, let's go ahead and close that off. Then let's go ahead and take the derivative of x to the third power. The power rule here, we can go ahead and say this is going to be plus 3x to the second power. All right, no need for a dy dx just because there's no y's here. And then finally, the derivative of 5 is just going to be 0 because the derivative of any constant is going to be 0. This first part's going to stay the same. Y squared times 1 is just going to be y squared, and we're going to take that away or subtract it. So we're going to write minus y squared. And then multiplying all this together and then distributing this minus sign to this term, that's going to be minus 2xy multiplied by dy dx. And then we're still going to have this plus 3x to the second power equal to 0. So using implicit differentiation, we just found the derivative of this curve, which we can go ahead and now plug in this 1, 2 in for x and y to figure out what this dy dx is, which is what the slope is at that particular point. Let's go ahead and substitute in 1 wherever we see x and 2 wherever we see y. After we substitute it in, let's go ahead and clean this up a little bit. For this first term, 2 squared is 4, 4 times 3 is 12. We can go ahead and simplify this to say this is going to be 12 times this dy dx. Now for the second term here, we just have this 2 squared, which is 4. We can go ahead and write minus 4. For our third term, we have 2 times 1 times 2, which is just going to be 4. So we're going to go ahead and write minus 4. But let's go ahead and multiply that by the dy dx. And then finally, we have 1 squared times 3, which is going to be 3. Let's go ahead and write plus 3 and write equals 0. 12 dy dx minus 4 dy dx is going to be 8 dy dx. Let's go ahead and combine those like terms. And then if we go ahead and combine this minus 4 and plus 3, that's going to be minus 1, and that's equal to 0. Finally, if you go ahead and add 1 to both sides and then divide both sides by 8, we can go ahead and say that dy dx is going to be equal to 1/8. So we had the original equation. We took the derivative of both sides, which is what we were doing right over here. In this step, we just simplified our derivative a little bit. In this line, we substituted our 0.1, 2 into the derivative. This step was just a simplified version of the previous step. And in the final step, we just solved for dy dx. Looking at our answer choices, it looks like B is what we got, so that'll be our answer.